Hey guys, welcome back to the channel. We have another ECM repair video, this time working on a 2009 Mini Cooper with an N12 engine. It's an R55. The customer name is Emilio Saror. I don't have where he's from, so I'm just going to keep it like that. I'm going to also to tell you the last digit of the VIN number, but when we jump into the repair, you will see it TX33421. Customer concern is no coolant temperature sensor reading. He said that he did wire diagram test, connector test, and everything, and I'm going to show you a little bit more as we jump into repairs. But again, code is 2F1A for engine temperature or engine coolant temperature. That is Mini Cooper BMW full code description or number. All right, but guys, let's jump into the testing and repair. Okay, let's see if we can fix this one. All right, guys, as usual, I got everything pretty much ready to go. I had the computer connected. Again, this is an N12 Mini Cooper R55. I'm not sure if I said that correctly at the beginning of the video, but yeah, so connections that I do before we jump into the actual test first. Let me show you those. Across pretty much the board on Mini Cooper, you're going to have on these N12 and N14 and N16s, you're going to have a three connector ECM. Let me get something to point. So we're going to have, with the majority of the connections that we need for communications are going to be on connector X6304. Then we have the connector 211, which I'm just going to refer by the last digits, and then connector 231. Let me just make sure I also have, or I'm saying that in, sorry, correctly. So yes, we actually will have, because it can be either connectors 231 or 211 or connectors 232 and 212, and that depends if it's an N12, N14, or N16, and so on with the same wash DME. Let me just get the covers because, as you see, I have the computer removed from its casing. So if you have this DME, the 7590A59, they will all have the same internals. All right. Oh, yeah, I didn't notice that, but yeah, you see the last digits of the B number also on the computer. That is pretty much always done with the original DME or BMW computers. All right, but so in the main connector, we have signals in the X604 that I need to communicate and power out the computer. So we have, again, on the X604, we got powers on 5, 16, 18, and then wake up line on pin 19, grounds on 3 and 4, and then the communication happens on pin 40 and 52. If you are trying to attempt, which I would not recommend, but to open the computer, you can do tests definitely. If you have a breakout box like this and a voltage supply or a battery, if you're going to provide the kind high and kind low through a box like this, and then you can connect your scanner as I'm doing in here, you need to supply a 60 ohm resistors in between the two kind high and low to communicate, and that will help you have a good communication, because otherwise it will not be established. I also mark in all the connectors where the 5-volt references are, and I have one right now in the connector X604 to see if 5-volt references are there. Now, I want to show you pictures of how the computer got into me, because talking to Emilio, he definitely showed me that he did the homework in there, and I asked him, can you please make sure the connectors are not damaged, corroded, or so, because it's also a common issue on these computers, and that can damage a computer. He said, no, I check everything, and everything is working good. Well, then, for my surprise, when I got here, and I'm going probably to add this photo to the video so you don't have to look in through my camera, because sometimes the refresh rate of the screen that I'm now using is not the same or as faster than what we see in the camera. But hopefully you guys can see here bent pins on the small connector, which I already corrected that, because I mean it was really bad. He's like, oh yeah, that might happen on the ship, and I'm like, I don't think so. In order for something like this to get bent, they will have to break the connector because the pins are in, not sticking out. So they will like, I mean, unless somebody poked that in there, I don't think so. And then if we go into the connector where the coolant temperature sensor is, which is in the center connector, as I have the connector connected now, or to do my test, we're going to have the black wire is in pin 14, which is the sensor ground for the coolant temperature sensor, and then the signal is on the green pin 32. Yeah, so I'm going to show you that in a bit, but yeah, I mean, look at the amount of corrosion that we have here. Sometimes, I mean, sorry, but I took this with my phone, and lately the pictures are not too good as far as that close up. But yeah, then again, the DME, so we can see that that is, again, it's being numbered, TX33421. I mark always the computers in cover because I got multiple computers in here. And then now the connections, you can see all the connections that I'm doing in here. And I just noticed that I have the kind of high, which I'm always using, kind of high white cable and then kind of low blue cable, but I already fixed that up. And then you can see that I took the time to really clean as much as I could and unbend because this is the small connector to bend the pins that were completely bent up. So I think I did a very good job in there and on the cleaning because the computer looks pretty good, but definitely I will now suspect that he shorted out or the computer got shorted out because of the water intrusion in here. So he's going to have to correct that. And the most common problems with this is cowls spaces, gaskets on the engine that are not covered, or connectors that are missing the actual weather pack. And that is very important. You can use dielectric grease. I will recommend you to not put the dielectric because remember, sometimes people misunderstand the term of dielectric grease and think that it improves connection, and actually it's the opposite. Dielectric grease is not there to improve connection, it's actually to not connect. So it's actually like a barrier. All it will do is remove or not allow the water to enter the connector and to short in between. So if you stick that onto the terminals, it will lose connection and that can become problematic. So if you're going to use dielectric grease, just put them in the outside of the connector so it seals the outside, but not in where the terminals are. Okay. All right. So that is one more, part of the puzzle. Let me go over to the actual vehicle information so you can see this as well. Yeah, as you can see, it's a Mini. This is again with the VIN number on esta. It's an N12 with an R55 engine. Sorry, uh, it looks like computer has not been programmed because I was able to see that with top down, but I will show you this in a second. Let me see what else I want to show from here. I already showed the connectors. Engine coolant system, yes. I want to show this, but I think I actually have it still on ISTA, so let's go over to ISTA. So what I do, and this is what I always try to show, because a lot of people is always gathering information with like identifics or all data. If you can or want to have your vehicle information as a technician, as an owner or so, you can access ISTA information. You don't need to have the car connected. You don't need a diagnostic, as I say it like an icon, in order to access information. And it's $30 a day, and you can access everything that that we're seeing here. So the way that I gather or I went into this information, I'm going to show you first what I got here, and then I'm going to show you how I got here. All right, so we have the engine coolant temperature sensor, and then we can see that one of the pins, the AT mod, is going into pin 32 as a yellow wire, and then on the other pin of the coolant temperature sensor, it goes to 14. 1 second, guys. Okay, I was saying, the white pin goes to pin 14 on the DME, and they're both in connector, as I said before, 211 and 211, right? So we got that. The numbers that you see here is what BMW always uses. So if you want to look for the coolant temperature sensor on the Mini Cooper, it's B6232. If you want to look for the DME control unit, it's A6000. And that is very important. But then how I know which one is the ground and which one is the actual signal, because, you don't get to see much in here, even though that for a technician I can definitely see that if I have terminal 31 is the ground. So this is almost telling me right there that this is the ground, and this is 15. So this is a transistor inside of the circuitry. They're trying to, to show you that this is probably where the signal is coming because it's going to a transistor and then into the microprocessor, right? But another way to find out is if you are using this information from ISTA, you click on overview and then you go into lines. So again, ATMOD. So ATMOD, it says signal temperature sensor. Perfect. MTMOD. Empty mud ground for temperature sensor. Voila, we have all the information that we need. So now we can see what are we missing on this computer after that water intrusion. Can we talk to this computer? Do we have fiber reference? And then can we fix this computer, right? So that's how you do the test in the vehicle as well. So you can, if you perform and you follow the recommendations that I am doing and or I'm giving you here, you can tell me, Mike, I am missing the signal, I am missing the ground. I know exactly what is the problem, at least in the vehicle and externally from the DME. I don't know the internals because that will be me, Mike Salazar Diagnostics, fixing the computer, but that will really, really help me pinpoint and get to work in your computer. All right, so how did I get into this information? Let me close this in here. So the first thing you get, sorry, let me vehicle information. Did I just close it? Active. Close active. Right there. All right, so vehicle information. The first thing or the first page that you get when you enter the VIN number of the car, because you can go into cases if you open a new one, is this what you're going to get. See, I already entered the full VIN number of the car, so I'm here, and then this is the first page that you get. So you get to know there is an N12 and there's R55 and latest um, eye level recorded on actually the BMW database because you're not connected to the car, but we don't really need that. After that, you can either click on search information or at the top, I start with vehicle management. And then what I do is you can either go into component structure and try to see if you click in the engine coolant temperature. So we know that, let me close this so we can go slowly. But we know that the coolant temperature sensor is B6232, right? So you go to components, right? Open components, components with B, and then you scroll down to B6232, find that number, right? Scroll down. I'm doing it with you guys. And I know that it's not much in there, but B6232, hopefully you guys can see that in there. It says engine temperature sensor. But the only thing that I noticed that I got is if I click in here, it's just the connectors. I don't have much information to see. So location of the connectors, and that's it. So that's not enough for me. All right, so the other way you can go in here is in the function structure, and this is how you will find. So you go over to the powertrain, and then what I would recommend you to do is just click on engine electronics and let it build the right side uh, to populate everything. If you are connected to the car with ISTA and ICOM, you get all these ABLs. The ABLs are the test plans, which are really important, really good, and help us technicians to fix the car faster. And then when you scroll down, you got FUBs are function of operation, so you can read about it. Like say, if we click on engine coolant system, this is going to tell me and tell us what is included or what components are part of that. Like we got the electrical fan, etc. The map thermostat, the coolant temperature sensor, where it's located, which is in this case on the map thermostat housing, and it's telling us that it's a negative temperature coefficient sensor. So it says the resistor is part of a voltage divider, which is supplied with 5 volts by the DME. The electrical voltage at the resistor is dependent of, let me just see the resistor. The coolant temperature sensor records the coolant temperature and the control unit. The coolant temperature is the measured variable for the following calculations. For example, fuel injection rate, and nominal speed. The coolant temperature sensor is supplied with ground by the DME, which, yeah, both the ground and the sensor signals are coming from the DME. We already saw that. The second connection socket is connected to a voltage divider in the DME, and this is very important. Um, Voltage divider. That's what kind of like the circuitry that we saw there. So if we have that voltage divider, that means that you're going to get a full fiber reference in here because it's already through a resistor. So yes, it is meant to be pulled down, but it's taken in consideration the resistance of that resistor internally in the DME and the resistor of the sensors. Based on the value and the voltage, the computer will do a calculation and knows how much amperage is drawn, if it's a short in the sensor, and that's more for diagnosis than everything, but this is definitely a new system. All right, so now we know more of that, but still, this is not enough. This is not what we're looking for. We're looking for wire diagrams. So wire diagrams in BMW are SSP and BMW and Mini Cooper. So we're going to get to coolant system, the same thing. So we click in engine coolant system, and this is how I got here. Now, when you open this diagram, you can again click on overview, again, right in the bottom right, and that will open and populate those submenus in here where you can click in components and lines. Now, we know that we are in engine coolant temperature sensor B6232, and we're looking for the AT mod and the MT mod, and we have it here, and that is how I know the signal temperature sensor and the ground for the temperature sensor. So now I have everything to connect and to test this computer and know what am I missing. All right, so I don't need ISTA no more. Let me see what else I have in here. You can also find the complete DME diagram in in ISTA if you go to A6000, and that will tell you, again, a little less informative of what the B6232 is, because this is all the sensors. If you want to know what all the sensors, you can go and, since we got it open, I can close this. I can go into the supply for the DME. Let me just see. Because in here, if we click in here, we will have just a voltage supply for the DME, and then everything else is divided into functional structure. If we go into component structure and we look for the DME, which is the A6000, right? And I hope you guys like all this information because I'm giving you a lot of information before even starting touching the computer. And this is how you do your homework and you repair a computer. So again, we're going to look for the A6000. And in this case, we do have a lot more populated. So we got SSP. That's what we're looking for. So in the engine side, which is what I'm looking for. The body side will be powers and grounds and like the voltage supply. So we got all the sensors, and then we can click on overview and then components before we start looking for what we got in here because it's just a lot of numbers. So we don't know nothing about that. But then now, and this is how I find out, as I was beginning to work in BMWs and Mini Coopers computers, the numbers of the sensors and everything. Now you memorize it. I mean, repetition is like muscle memory. So you get to learn all that. So and we get the B6232 engine temperature sensor. If I click in here, which is good, you see this zoom in here, so I will click in there, it will zoom exactly where this sensor is located, and then B6232. I can also here check on the lines in AT mod, which it should be here, and it is AT mod signal temperature sensor, and then MT mod, which is so that was AT mod, and then MT mod is ground for the temperature sensor. And again, if I click on here, it will take me. If I, let's say, zoom out, let's do that so you guys can see that. Because if I am zoom out and I want to locate a signal, I can just click. I'm here, right? If I click, and I forgot that I'm always using this is a touch screen. If I click on that zoom, it will take me over to the sensor, which is right here. And now I zoom a little more. I can do the same onto the empty mod, and that will zoom again into line. Now we are in the AT mod and the empty mod. So that's how you do it. All right, guys. So again, another way to find out where the pins are, and you can see also that these are two in connectors to 11. Obviously, we already know that. So these are X60211. And also remember when you got data lines in here, that means that this is not the full connector view, and it might be more, but it ends in here. So now you see that we have dotted line. So all that from here to before are in connector 211, and then now is connector 212. So that's the division in there, because it looks like this sensor, whatever this is, and we can actually see. So let's see what that component is, because I don't know by by memory that one, but the X6 203A B6 right here. That's the crankshaft position sensor. All right, so the crankshaft position sensor has two signals or two wires on the 211 and one in the 212. And you know, again, you can now find out what those are if we go to lines. And this is pretty easy because, I mean, we already start to understanding how these wire diagrams work. So if we go look for PKW, PKWG, that's the signal. So PKWG is the signal. Let's look and see what the MKWG is. So MKWG is now a ground. So now we are also understanding that M's are mostly referring for ground. So anything that start with the M is most likely a ground for a sensor. And now let's find out what the UKG is. So we have to scroll down into the UKG supply. So we have a three wire sensor, and this apply to all three wire sensors. You're going to have a ground, a power, and the sensor signal. For the thermistors, air temperature sensor, coolant temperature sensors, anything that is temperature transmission temperature sensor, all temperature sensors, most of the times when they have thermistors, you're going to have only one, two wires. And it can be even a one wire too, because if the design on that vehicle has grounded through the block, which most new designs have their own sensor ground, so it's not dependent on a ground on the block, because if the ground on the block is bad, this is a main component and start to run bad, and it's just a bad or a dirty ground on the block, and that will remove that from the equation. So, but in all vehicles, you were able to see a one wire sensor, and it's because the ground was provided on the block. But yeah, most thermistors, more newest design, is a two wire sensor. All right, guys. So again, enough information. I've been talking for 20 minutes and we haven't even tested the computer. All right, but let's go back to, or let's go up to the test. All right, so I have the scanner ready to go here. Let's power up the computer, and I have the oscilloscope connected to kind of high, kind of low, and my channels are the blue and the red channel, and I have the green channel on the oscilloscope connected to the signal for the coolant temperature sensor. So let's power this up. We immediately see that we have communication, and it looks like a nice nice looking waveform. 5-volt reference is great, so I have no issues with that. Let's do an auto scan. Remember, we're looking for the last digits TX33421 to make sure that this is the correct computer we're working on. And I mean, mark it on the other side. I don't suspect to be anything else. And Mini Clubman TX33421. All right, we're going to go and click into Quick Access. All right, one thing that I immediately see is we do have the voltage for that coolant temperature sensor in here, because we got 3.403 volts. By design, I know already that that is okay. Remember, we're going through a resistor and then sending the signal. It's a comparator. The computer used to compare and knows exactly the resistance on the sensor is correct or not. First thing I'm going to do is read the fault codes if we can get to connect. Come on. All right, perfect. Um, let's do manual selection. Because remember, this is the actual scanner is trying to talk to a gateway, and we only have the DME. So let's select it by manual selection. We know that now the bean is correct, and we're going to click into R55, into drive, engine computer. Sorry if I'm going a little too fast, but I already used too much time on explanation, which is good. We got the last digit of the VIN number. Again, everything is good. And we can see the last programming date, 14/10/2008. So this computer has never, oh, actually, no, let me rephrase that. That's the production date. The last programming was in 7/1/2011. So it did have one programming, but it's not up to date as far as programming. All right, let's continue. We're going to read the fault codes and see if we have the 2F1A, and we do. So it says coolant temperature sensor signal. It shouldn't, because we got everything that that sensor needs. So we're definitely missing something, and we know that it's not the the sensor signal. So are we missing the ground? All right, so, or the ground circuit, because remember, this is not just a ground, this is actually a circuit. This is a specific design for Mini Coopers and and BMWs. You want to display? No, I don't. All right, so let's read the data stream. We're going to go into temperature values. I mean, the only one that we're going to look is the engine. We can actually select, let me see, inside temperature of the DME, because this has an inside temperature sensor. And then, yes, that's a DME temperature, 75 something. But so we got 68 degrees. Let's see if we can change that value, because I'm very let me see, very used to with 400 ohms to have around 160 or so Fahrenheit, not that low of the temperature. So let me put 9,000. This should take it over to like minus, and that is not even moving. So we are definitely missing something. So the signal is not being pulled down to ground. So the other way that we can do this to make sure that we are indeed missing a ground is supply a ground. Can I connect that in here? Because we know that we have that voltage. So I'm going to disconnect the green one. It's going into the sensor ground, so that should be okay. And we will know if I'm actually indeed doing that. Actually, no, I don't have to unconnect it here. Give me 1 second, guys. All right, so what I did is I removed the green wire over to the ground from the computer, the ground circuit, and I'm now supplying just a regular ground here through, obviously, my decay box. And guess what happened? Okay, we went down to 51.8 degrees. I was expecting to have more. So let me, yeah, but we're definitely, now you see we got minus degrees. So that now is reading. So let's go into a higher temperature. And now we got, overheating temperature of 199. So I don't want to like leave it too much in there, because I am not sure, with this EME, the values are not exactly as I thought it was. Because let me put this in like 1400 ohms, and we got 100, and we have to wait for that to stop. But we can definitely see, yeah, 132 degrees. So we can definitely see that the computer can actually read. So this is a very good high hopes. I don't see a damage in the microprocessor. I can see a damage on the circuit of the ground for the sensors. And obviously that was created because of that water intrusion and that connector. Most definitely, he's going to have to clean that connector. And that for that, I'm going to recommend you, Emilio, please try to get this. This is probably one of the best products, and I just have it sprayed on my hand, but get this dioxide D5. You can find this in Amazon. It's not that expensive, and it removes oxidation. All you have to do is spray the connector very, like, not gently, very, like a lot. I was trying to give a fancy word, but yeah, but you want to make sure that you add a lot of these to the connector, and let us hit for at least 2 hours, and then you can use one of these plastic brushes or something like these, or a toothbrush, and then go inside the connector and remove all that green crusties that you now have in there, and then spray with like air. Do it again, like at least 2 3 times, waiting an hour for the chemical to actually react, and then clean. And then last, you can use a contact cleaner or alcohol. Make sure that you are careful when you're doing that with the actual weather pack on the on the connector, and then just use air immediately so it doesn't damage the weather pack if it's not already damaged. All right, but yeah, that's what I would recommend you to use for your computer. All right, guys, this will be part one testing. I have to contact Emilio and give him the good news that I can indeed repair his computer. and see if he approves, which I know is going to, because I mean, he wants his car running, right? And I know that dealer recommended to replace the engine harness, which I am not sure if there are too bad for what I see, but that wouldn't have fixed his car because he had a problem with the actual DME. I know this is the main problem is here. This is not the like, let's say, by correcting this, now the computer will read, but he still has issues on his harness, and we can see all that corrosion in there. That has to be corrected, that has to be fixed, because if that water gets in there, it can damage the computer to a no repair possible, because I mean, water is short electricity, and it can damage the whole internals on the computer. So Emilio, if you're watching this, you're going to have to fix that connector, clean, like I said, and seal it really good. If you want to use, again, use dielectric grease, make sure that you apply it to the outside of the connector, and then you plug the connector. You don't put it here. You put them in the ball connector on the outside, so they're not touching the terminals, and you just squeeze them in with, close to where a weather pack is. But for the rest, I am having high hopes in your computer. I definitely will contact you and see if you approve the repairs. All right, guys, if that's the case, I will probably just add that to this video. Otherwise, this is the end. But if it's not, then expect to see the results on this one. It's already a little too long, so maybe I just do part two to not make too long of a video. This has a lot of great information, and I'm not just do a short video for part two, the repair. So stay tuned, and hopefully we get to fix this one too. All right, guys, don't forget to subscribe. See you next time. Bye bye.